Logic Gate tutorial and worksheet. So reading from the screen. The best way to analyze a logic system, sorry, a logic system is to take it step by step, labeling your outputs as you go. Note I say labeling your outputs. Let's try an easy one. So I have here A input, B input. If you follow, A is going through a NOT gate, B is also going through a NOT gate, and the outputs from that go through a NOR gate to give us Y. So the best way, as I always say here, this is what your circuit would have looked like normally. Just A, B, the two NOTs, the NOR, and the Y. So if we want to analyze the circuit and see what the output at Y, what we will get. So the first thing we do, we always label our outputs just to kind of give us some structure. So if you can see, A will pass through a NOT gate. You all can choose. I like to move alphabetical. If you want to label it all kind of weird ways, go ahead. So A passes through a NOT gate to give C because it's going to have a new output, as I said, labeling your output. Output is when you pass through a gate to give you some signal. B passes through a NOT gate too, and the output for B passing through the NOT gate will be D. And C plus D through a NOR gate will give us Y. So when we're doing our tables, now we can go ahead and write down our stuff. So if we were given this table normally, right, if we were given this table normally, what I would do, I would just extend my table to put in all my intermediate steps. All right, as I said, you can use as many intermediate columns and steps as necessary. Now, you don't have to go and make too many because we only have 3 gates here. So we should only have 3 extra columns added. So I have A and B. I know C will be, let me just scroll back up a little bit, wait a little bit. All right. I know C, I have output C, D, and Y. And what I usually do, you don't have to do this, but I tell students to try it. Or this is what I do personally because I get lost. As easy as logic gates is to me, I will get lost unless I label everything really well. So it helps to write on the operation being what's being added or what's being changed at the top to keep track of your circuit. So you can just jot it down in pencil. It's not something that you have to write, so forth. So if you look here, C is the NOT of A, D is the NOT of B, and Y is C plus D through a NOR gate. So once you have all of those labeled, we could go ahead now and perform our operations of in your truth table. So let's see. What does a NOT gate do? It reverses your signal. So we're looking at A. If A is 0, you're going to get 1. A is 0, you get 1. A is 1, 0, and 0. Simple. Similarly, for B, we're just going to be reversing whatever B is. So you're going to get 1, 0, 1, 0. Simply enough there. And then what we're going to do, Y is C plus D. So now we're looking at the C plus D column, right, which are these two, right? C plus D through a NOR gate to give us our output, Y. Now, how does a NOR gate work? I don't expect, I really do hope you learn it by exams. I think I did put it in the handout. Let's scroll down. So a NOR gate, how does a NOR gate work? It's the opposite of an OR gate. All right. As remember, I told you all, you just have to learn your 3 basic gates and everything after that. Well, okay, XOR and XNOR, you have to learn. Not even that. These 3 gates, you have to learn. The rest can be worked out from each other. So NOR gate is the opposite of an OR gate. So when both signals are low, then we will get an output of 1. Every other combination gives us an output of 0. So only for NOR gate, when both your inputs, this is your input A and B, or in this case, whatever the 2 inputs are, once they're both low, our output is going to be high. So let's go back up to our table here. So you can see when I have 1 and 1, you will get low. 1 and 0, low. 1, 0 and 1, low. 0 and 0, 1. And that's how we do our table. Right? And this is a good way, especially when you are in the exam stress and exam rush, and you're rushing along and you want to check your work. Trust me, you all don't want to have to be figuring out again your logic gate from scratch in exam stress. Take 1 minute, not even 1 minute, 30 seconds at the start of the question to label everything down and write down your table properly so that way you can track it easily. So let's check another one. So that was simple enough. So let us now look at how we work with a logic gate where we have signals that are shared. Sometimes we can share a signal because we know we can take any circuit in regular life. You take a circuit and we could break up that circuit if you have a battery here. And we could break up that circuit and send our currents in different directions. All right. Similarly here, we can break up the input to a logic gate, right? So if this is our logic gate, we can break up the input and send it somewhere else, which is what we're going to have here. So let's look and see. We have, getting rid of these again to start from scratch. All right, I have A and B. Now let's look and see what A and B is. A and B are going through an OR gate. We are taking some of B and feeding it both into the OR gate, and then we're going to take some of that signal and also pass it through a NOT gate. So this means the signal B is being used in two gates. We can't do that because it's electricity. We can go and send signals wherever we want. So we have O, all right, and then we have a AND gate at the back here. Now let's label our gates or label our outputs as I said how to do before. All right, now if you don't want to do it, there's no hard and fast rule that says you have to label your outputs. But this is just, a guide to somebody, from somebody who's been doing the topic and found that it was helpful. All right, but if you can keep track of it in your head, by all means, go ahead. Some of you all can track 500 things in your head at the same time. I can't. All right, so I will set up all these little intermediate steps. There's no shame. Nobody says you have to go through all the intermediate steps. I'm just using what I use. Right, so let's look and see what we have here. A and B go through the OR gate to give C. All right, then if you look here, we are taking some of B, passing it through not an OR, NOT gate, and I will get D. And then I go ahead and let's put NOT. And then I see I have C plus D through an AND gate to give me Y. So I now know all my intermediate steps, right? So I can label my table, I can add my extra columns and whatnot. So I will still write it down here, right? C is A plus B through an OR gate, just to keep track. D is B through a NOT gate, and Y is C plus D through an AND gate. So let's go ahead now and analyze our circuit. A and B through an OR gate works such that as long as a high level is present, you are going to get your output as being high. So low and low, low. A high level present, you'll get an output of high. High level present, output of high. Both outputs are high, so you also get an output of 1. Simple enough. D is the NOT of B, so we're just going to see whatever we have for B here, and we're going to reverse it. So where we have 1, it becomes 0, and when it's 0, it becomes 1. So I'm going to get 1, 0, 1, 0. Now we're going to go and combine both C and D, right? So we're looking at both C and D, which is these two columns, C plus D through an AND gate gives us Y. And how does the AND gate work? Both inputs must be high in order for your gate to work. I really hope, if I were you, for the online classes and online doing work, have these written down. Not just printed out, written down so you can easily refer to it to have to scroll back up through the screen, right? Or ask me, miss, you could scroll down there. No, that's a little too annoying to do. Write out your gates until you learn them, right? See how I remember just what the gate does. So that way it's easy to analyze the circuit. And how does the AND gate work? When both inputs are high, we get an output of 1. So I'm going to see that I have 0 and 0, 0 and 1, both inputs are not high. 1 and 0, both are not high. 1 and 1 are both high, so you will get an output of 1. 1 and 0 also will give you no output. Everybody, you all follow that well enough there, right?
Yeah, miss.
Okay, good. So I'm gonna have you all try one. So here's, I'm starting you all up on one from the worksheet. All right, so this is question 6 in the worksheet. So I've color coded it. Hopefully you all could follow it. So, but let me explain what's happening right now and you all will see it. I'm sure it's pretty much easier now that you've had the explanation. So let's see. I have signal A. I have A and B. A and B are going through a whole lot of nonsense. All right. Now the tip I gave here, a single input NOR is also a NOT gate. Similarly, a single input NAND is also a pen. Hello. All right. Is also a NOT gate. So that's the one note you needed to know from before. So let's track and see. All right. I have one of A going into my, this is a NOT, NOT, and 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 or. So what's going to see? Let's say we have A going to AND gate, and then we're taking that A signal. Since it's only one coming into here, we can kind of treat it as a single input because it's only coming from one signal. So we can kind of do this in our heads. This is what's happening. We're going to have a single input NOR, and a single input NOR is essentially a NOT gate. So we can rewrite it like this, where it's just one input going into our gate to give us NOT. So labeling our outputs, A is going to pass through your NOT gate to give C. So we're going to have C. And now let's look what we have here. We have B going through an AND gate, and B is also being fed through another single input NOR. And as we said, single input NOR is essentially a NOT gate. So we can basically rewrite this over, imagine that this line here doesn't exist. All right, this is what's happening here. You're going to get a single input NOR, which gives you a NOT gate, just like how we did before where we shared our signals. All right, so B is going to go into the AND gate, and then B is going to be funneled through here to give us D. So D is going to be the NOT of B. So we have all our intermediate complicated little inputs. So let's now look at how we have our circuit to analyze. So we have both C and D. We know what C and D are. Now let's look and see. A plus D, so this is A signal and this is D signal, pass through an AND gate to give us E. So you can say A and D through an AND gate gives us E. I have it color coded, hopefully you're following. Now let's look at the next gate. B and C pass through an AND gate to give us F. That's why it's in the bright green. And lastly, if you look here, we have both E and F passing through an OR gate to give us our output. So we are going to try this right now. I did start if I gave you the final answer. All right. So somebody, let me don't have to call people individually. You all can take like 2 minutes to work this out. I'll pause the recording. And when we're ready, we'll start it back up. So 2 minutes to analyze this circuit. Okay, we should be finished. All right, it's just putting ones and zeros and checking a table. So somebody call out C for me.
C will be 110.
Hold on, sorry. 1100. Somebody call out D for me. Somebody else.
1 0 1 1.
1010. All right, because it's both not gates. Somebody call out E for me.
0010.
0010. Correct. Somebody call out F for me.
0100.
Correct. And to give us our last one, our OR gate, remember you need at least a high signal for it to work. So that's how you get when you look at these two. Let me get my purp, my lilac. All right, so 0 and 0 will give you 0. 0 and 1 will give you 1. 1 and 0 will give you 1. 0 and 0 gives you a 0. All right, so with that done, let me just assist you all in labeling the first one in the worksheet, question 1. So you all can go ahead now and try the rest of the worksheet. All right. So why I wanted you all to do this, because what we are going to be doing today, let's look at this first diagram. You see in S and CO. All right, what we are going to be doing today. Hold on. What we are going to be doing today was the applications of gates, where we are going to be doing this, which is the same output of what we are going to have down below. So it's going to be a start or a jump into the handout we're doing, the rest of the handout today. See why all this, there's a rhyme and reason why I give you all stuff to do, Let's just go and see if we get this out. All right, so for the tutorial, back to the tutorial. All right, so I have here a really bigger, much bigger diagram of what they had before. So I have a whole bunch of gates, all right, to give us two outputs. We have an S output and we have a C output. The S is actually called your sum output and the C is called your carry output, but we'll come to that when we reach the rest of the handout. So let's analyze what we're doing. First things first, label your gates, label your outputs. See who is going where. So let's zoom in a little bit. All right, I like logic gates. I find this fun. All right, once you learn them and get over your little headache thing. So first thing first, let's label them. This is a too big of a pen. This is an XOR. This is also an XOR gate. This is an AND. This is an AND. And this is an OR. So we now have all our gates labeled. So now let's label our outputs. All right. You don't have to use a marker, but if you look here, I have A plus B. Now I already have a C here. So A plus B through the XOR will give us D. All right, following again with the marker. If you look here, I am now going to be taking B and A. So the B and A are running through two logic gates. All right, so it's now going to run through an AND gate. So since we have A, B, C, let's label this E. All right, now let's get our other output, our closest gate. If you look here, I'm going to take D funnel it down to here and add it to C. All right, so D, E, and you'll get F. And let's look at the next piece of combination gate. So you see, you need to take your pencil and kind of just follow it through. All right, now if you look here, I am going to take D and I'm taking sum of C and passing it through the XOR gate to give me S. All right, so that's your S here. And lastly, by following the gates through, F plus E through an OR gate gives us your carry output or your CO output. So we have those down. What we can do now, write down what each one is in the top column, the top row, just so you know, so life doesn't get too complicated. It's complicated enough as it is. So what is D? D is A plus B. Oh, good Lord. It does this. Hold on. All right. D is A plus B through an X OR gate. What is E? If you look at E, E is A plus B through an AND gate. What is F? F is, if you look here, fall in the green, C plus D through an AND gate. What is S? S is, following the inputs, C plus D through an XOR gate. And what is C naught? C naught is E plus F through an OR gate. So that's simple enough. We know what each one is going to give us. So you could go ahead now and start up your and do your analysis of your logic gate. So look how it looked complicated to start with, but if you just follow it through and label as you go, you're going to be pretty okay. All right, everybody have, I hope you copy that down because we're not doing that now. I'm just starting you all up. Chat. I did it right. Yay, great. All right, so you see, it's just something you have to just take a minute to do. Settle down yourself, right? Rather than look at it and go like, what on earth? Number one, you all would never get this complicated for your sum and carry circuit. Your sum and carry circuit is a much simpler circuit. All right, as in your sum and carry circuit. Come on. All right, is simply this. So it's just an XNOR passing through an AND gate. All right, at the end of the day, all of these works out to just being an XOR plus an AND gate. But we can take far more gates to give us the same thing. So here is just a practice on how to do your analysis. So that's question one. Question two is really easy. Look how easy that is. That's just feeding through. So you label your stuff. Now, you don't have to label them as I gave you them, but this was just to start you all up. Really simple gate there. True, you're going through an XOR, a NAND, and a NOR. All right, really simple gate too. All right, something like this. And let me show you what something like this means. Something like this, you see this symbol here, or whatever this happens in your circuit. Anybody knows what this means?
Bulb, I like bulb. Where would the circuit look like?
Nah.
Or the wire that's going over it?
Yeah, those are two separate wires. This is not a junction. All right, so that means X and Y are independent of each other. Usually, we used to make the thing, look like how they had the other questions above where they just made no distinction of a junction. Whenever we have, and they want to make sure you do not make that mistake, when you have this little curved piece of wire, this means that X and Y are not connected whatsoever. So these are two very different wires. They do not feed into each other. They do not split up into each other. All right, so this is going to be helpful when it comes to seeing where you're going. So if you had done, just to say, all right, this is, if they didn't put this down in the diagram, and because it did show up in the diagram like this, suppose they had done this instead, all right, you will know which is going where, right? Is it coming here? Is it coming here? Is both the Y and there going in the next place, right? So this is why it's really helpful to have your signals go through. So if you form, all right, if you look here, let's just follow the diagram just now. They want me already for Parents' Day. Hold on, pause the recording. All right, resume recording. So let's see how this will work if you had to use this question or had to analyze this question. Really simple, right? You're going to get X passing through a NOT gate to go to your NOR gate. But then you're going to take some of X and funnel it down, and it's going to now go through a NAND gate. All right. Similarly, we're now going to take the Y and break it up and send it all over. But Y here is independent of X, so it's a separate wire. And when Y reaches this junction, it splits up and goes into the NOR, and then it goes into the NAND. And both of them, you combine the outputs of both of those through your OR gate to get your output. All right, everybody. So that ended up working out to be quite a simple circuit to analyze. It's just this little piece here, right? You might have gotten lost in sending your signal in the right place. All right, so that is the questions there. So please give them a try. If you all want to try it right now and then we go on to the handout next day, we can do that. All right, but we'll just stop the recording and I'll put up the solutions. What you all want to do? You want to do this now?
I don't mind.
If it was in school, we're doing it now, you know, so.
Yeah, I know.
All right, because we're supposed to be getting work done anyway. All right, so you all, what do you want to do? You want to go on to the next part of the handout where you might be a little lost because you don't know your gates by heart, because you have to know your gates, you know, ow, I'm trying to snap my finger, that hurt, right? Really, really quickly. You have to be able to analyze any sort of logic table, logic gate really quickly. All right, so let's go through this. Yeah? No? Besides Jabari, anybody else?
Yeah, Miss, we could go to them.
Okay, good. Let me stop the recording. All right, so for those who are watching the recording, you'll have to, I'll put up the solutions in the class afterwards.